And if we were to understand even better what containment means, we need to look at it from two perspectives. So from the user's perspective, this usually means, can I control or not the system? And in practice, this can mean, can I undo or reverse actions? Can I stop or interrupt the system? Can I escalate to a human? Can I control what data the system has access to? And so on. Now, from the product perspective, not everything needs human approval. So low-risk actions can be autonomous, medium-risk actions might act and notify, and high-risk actions should confirm first. So thinking about these two perspectives, then containment really becomes the design of permissions. Much for having me tonight. My name is Gabriella. I'm a product designer. For the last few years, I'm working mostly in highly regulated industries, and for the last year, I'm focused on AI and agentic systems, trying to understand them and make sense of the chaos. My goal tonight is to leave you with three things. One is how to spot agentic behavior in products today, how to map it as a service, and we'll talk a bit about the guardrails, the handoffs, and human control points. Now, before we talk about system design, before we talk about system design, we need to be clear on the language, because AI and agentic are the buzzwords of the year, and they are plastered everywhere. They often mean different things to different people. When I talk about agentic systems, I mean a system that has a goal, decides on steps to reach that goal, and takes actions on humans' behalf. So the key difference here is not intelligence, it's agency and autonomy. Now, some of you might be asking, but haven't systems always done this? And you're right, systems always had goals, made decisions, and even acted on humans' behalf. The difference was the traditional systems were hiding these decisions behind deterministic rules or predefined workflows or back office processes. Coordination happened between humans through tickets, dashboards, and actions usually waited for a human to move things forward. What's new? It's the speed and the scale. Now these new intelligent systems are the goals are explicit goals. An action can trigger another action automatically without waiting for a human to move things forward, and the failures scale much faster. And now if we were to talk about agentic behavior in products today, of course there are many products, like really we can explore them and analyze them. There are many. For tonight I chose the most accessible ones. One on the left is Amazon Rufus. This is Amazon Shopping's assistant. And the other one on the right hand side is Amazon Buy For Me, agentic and fully autonomous feature. The Buy For Me feature is not available in the UK right now. It was released as a pilot in the US for selected users. Now, if we were to look a bit at Rufus, Rufus displays agentic behavior in the discovery and discovery phase, and falls back on traditional payment systems. So basically, it helps you explore and find what you want. But when you're trying to actually pay, so the commit phase, they fall back onto the traditional payment mechanisms. Now, on the other hand, the Buy For Me feature is an agentic autonomous feature which got a huge backlash. And what they did, they scraped the internet, and they basically took, without other shop owners' approval, they listed their products on Amazon without asking them for permission. And oftentimes they didn't even include the right images, product images, the thumbnails. So you can imagine the rage, and actually you can go on Instagram and have a look. just type Amazon buy for me, you'll understand how upset shop owners are. Now, we shouldn't be naive to think this was a bad product decision or a bad business decision. Amazon is trying to push the limits and to redefine what e-commerce even means. If you heard the discussions last year on machine customers or agentic commerce, this is it, it's happening. The problem here wasn't bad decisions, probably was lack of infrastructure, and I'm sure they are working on it as we speak. Now, does this mean everything becomes fully autonomous on the internet? No, of course not, and this is another misconception that a system, if it's not fully autonomous, it's not agentic. Autonomy lives on a spectrum, and it's tied. It's closely related to the agentic life cycle. So a system can act and suggest in the discovery phase. It can act in the evaluation, but might need to confirm. And then it should never be fully autonomous in the commit phase. The commit phase is where money flows in, when often irreversible actions happen, even life or death decisions. And I mean, as an exercise, think about someone with a person with a severe disability using a system, and the system deletes all their files. So that's a life and death decision the system made without their approval. And now most real systems today live somewhere in the middle. They allow autonomy in low-risk phases, and they contain it in high-risk phases. And this leads us to one of the biggest problems of the AI industry today, and probably for the next few years, containment. And containment, because containment, why is containment such a big problem? Because it creates binary failures, so the users can either control the system or they cannot control the system. So it's that easy. There's no middle ground there. Now, this is critical because of regulation. Both the EU AI Act and the ISO 42001, they require proof of containment for products that operate on the EU market. Of course, I think the regulation will change as these systems become more mainstream. Now, of course, there's also reputational damage, there's legal liability, this high-risk deployment, slowing down production, and there's trust. And trust, I think, good containment will become a market differentiator in the future. And if we were to understand even better what containment means, we need to look at it from two perspectives. So from the user's perspective, this usually means, can I control or not the system? And in practice, this can mean, can I undo or reverse actions? Can I stop or interrupt the system? Can I escalate to a human? Can I control what data the system has access to? And so on. Now, from the product perspective, not everything needs human approval. So low-risk actions can be autonomous, medium-risk actions might act and notify, and high-risk actions should confirm first. So thinking about these two perspectives, then containment really becomes the design of permissions. And this is not about fear. So containment is not anti-agentic or anti-innovation. Containment is about responsibility, it's pro-safety. And paradoxically, the less authority a system has in the beginning, the faster it can safely move toward more autonomy, because it learns, the users trust it more, and so on. And how do we design these systems? Now, the moment a system can act on its own, you stop designing screens and interfaces, just screens and interfaces. You design a service. And that means we'll be designing the front stage, what the users see, and the backstage, everything that has to happen behind the scenes. How agents coordinate, what context must be preserved between handoffs, how the system fails, what's the cost of failure, and more important, how humans experience all this. And for today, I prepared a very basic example. Please don't judge. Like this is really a very simple blueprint. So this is a multi-agent system, multi-agent e-commerce system blueprint for a returning customer. Now, for the user, this usually is very simple. So the user makes a request. They see a few updates. They might be asked to confirm or not. They see a few more updates, and that's pretty much all done. Although this might look, so this example, it's a chat UI. So this might look like a chat UI on the front stage. On the back stage, this is actually a distributed system where agents reason, make decisions, and act on users' behalf. This is and some of these decisions need to be a design concern, because if you really think about the UI becomes a reaction of all these decisions made in the backstage. And this means, where do handoffs happen? What happens if one agent fails? Does the entire flow stop? Where does state leave? What the system needs to remember? What do you log for audits? And so on. And most important, of course, what can users control in all this? Can they stop? Can they undo? Do they even understand what's happening? So this isn't engineering work. This is system behavior design. And moving a bit forward, I always get this question. So it's about the user intent. And in this example, the user intent is it's the happy scenario when the user knows what he or she wants. So it's buy me the cheapest lean startup book. But in reality, people are unpredictable and they can ask for anything. Now, does this mean agentic systems need to support all user intents? No. They are built to support a bounded set of intents, like apply constraints and then behave safely within those constraints. And what does it mean? If the system, so if the request is approved and clear, the system may act. If the request is unclear, the system needs to ask clarification questions. And if the user intent is high risk or unsupported, then the system needs to refuse gracefully, or provide alternative options, or escalate to a human depending on the risk and the domain. Let's talk a bit about what can go wrong, because things always go wrong. Now again, this is a very simplistic example. In real world, this failure analysis would contain many more failure scenarios. Now, here I prepared 3 examples. So what can go wrong? First scenario is when the shopping agent fails. So this usually means the product is unavailable. This is a low impact failure because no payment has been processed yet. What does it mean? The user provides alternative search. The system suggests similar items. Now, scenario 2 is when the payment agent fails. We're still in the safe fish area here because still payment hasn't been processed yet. Now this usually means card has been declined. So the user updates payment info, the system retries payment. And now scenario 3, when the delivery agent fails, and that's a high impact failure because payment has been processed. So this usually translates in real world as refund requests or customer support tickets or even chargebacks. Now, here's the thing. This scenario 3 in a real well-designed system should never happen, because when you properly design a system, you would do the validation of the delivery availability before you try payment. So in this example, that validation would happen somewhere here, and the shopping agent's tasks would be to check for availability, for stock, and to see if that item can actually be delivered to that address, and only then hand off context to the next agent. So that's why sequence matters, and it's not like these decisions on where do you place the handoffs are not just for the sake of designing flows. Their main purpose is to minimize risk and contain failure impact. And as we saw, agentic systems don't fail like screens, they fail like services. So failures usually, most of the times don't happen in the interface, they happen between systems. And because we are getting closer to the end of this presentation, I really want to point out what actually does design own in agentic systems. Now, no matter what the tech stack your platform is using, engineers are building the capabilities. They are building the orchestration, the tools, the memory, the workflows, and then design shapes how these capabilities behave in the real world. Now, this is the layer where trust and risk are being shaped. And if you ask me, it's the most important one. And now, in our daily jobs, I think, designers probably will work less on polishing screens in the future and more on blueprints, flows, and diagrams and thinking. Now, and if you really think about it, none of this is really new. Like, regardless how much autonomy a system has, we've been always trying to solve human and business problems. So nothing really is new here. Now, the difference now is these systems are much faster, complex, and more independent. And I think this means design is moving upstream. It's not about becoming developers or engineers overnight. It's about designing and owning system behavior. And I think that's a very good place to be in. Thank you. Thank you very much. Thank you. Coming? If you have any questions, sorry, I forgot. Yes.
Hi, my name is Martin Hilker.